Hello all and welcome to the algebra video for equations with infinite or no solutions. Okay, so these equations are going to look very similar in that they are exactly the same types of equations we've been working on in terms of equations with variables on both sides, multi-step equations, so meaning you're going to have to do some sort of distributing, combining like terms. But once again, all the same types of questions, except for we have some special things that happen sometimes when we try to solve equations. Okay, as you can probably guess, sometimes you can have equations that have no solutions, as we're getting ready to see here in just a second, or we could have equations that have infinitely many solutions, meaning every number that you could possibly pick could be a solution to the equation. Okay. So with that being said, let's look at the first equation here. And I'm going to zoom through pretty quick on how to solve these equations because once again, uh, everybody at this point should be able to solve multi-step equations with variables on both sides. So all I'm doing are the same steps that I would to solve any equation that we've done up to this point. Okay, I'm hoping this video will be pretty quick because we're going to look at some examples because everything works exactly the same, except for we're going to see some examples of some special cases where in the process of solving our equation, we see something special happen. Okay. So to start off, let's look at this equation where we have where we're already told we're going to have no solution. So what makes it to where this equation is going to have no solution? Well, if you look at it, it looks pretty normal, like a normal equation that we've seen before. Okay, so let's go ahead and just try to start solving this. Okay, so we see the parentheses, so that means we need to distribute that -4. So -4 times 2x gives me -8x, plus -4 times 1 gives me -4. And some people might see where this is kind of going. Okay, so we have -8x plus -4 after we distribute on the right or on the left-hand side. And that's equal to -8x minus 2, which is what we have on the right-hand side. Now, some people say, well, we have -8s on both sides, but what does that really mean? Well, that means this number, whatever it is, whatever x is, if we plug in x, this number is going to be the same as this number. So that means we're going to have a number plus -4 is the same thing as, and let me fix this just for a second because I want it in the same form. So I'm going to write it as a sum, meaning I'm going to take this minus and make it, but I'm going to have -8x, so whatever this number is, plus -4 is equal to that same number plus -2. And you can kind of see maybe where this is going is that's actually impossible. We can't have a number plus -4 be equal to that same number plus -2. That can't ever happen. And we can see that by just following the same steps as solving equations with variables on both sides. So if we add 8x to this side, we have to add 8x to this side, which, once again, the whole point here is we want to get rid of that 8x, but it's actually going to get rid of that 8x on this side too. Okay, so all we're left with here is -4 is equal to -2. And once again, once you see that, that looks kind of weird. We get no variables here whatsoever. And when this happens and we get something here, once again, -4 can never be equal to -2. That means those can't be equal and that can't be equal. So what this tells us is if we're solving an equation and we get down here to something that makes no sense, like -4 is equal to -2, that tells us that there is no solution. Okay, so you can simply just write the words no solution, or we do have a symbol that we can use to mean no solution, and it's basically like a 0 or a circle with a line through it. And what that symbol right there means is that's the empty set, meaning there's a set of numbers with nothing in it because there's no answers to this equation. Okay. So once again, the whole point here is you're solving your equation like normal. Okay, so we use the same steps that we did to solve any other equation like that. The only problem is when we get down to the bottom here, we get something crazy like -4 is equal to -2. And you'll see another example or two of this as we go forward, but that's pretty much it. These equations work exactly the same. It's just a no solution equation. You get nonsense down here. Okay. Now, when we look at an equation that has infinite solutions, okay, what we mean by that is any number could work in the equation. So we could plug in any number and it would actually work. So right off the bat, you can see it's kind of hard to tell. I can't see that this is not going to have that this is going to have infinitely many solutions from here. So we do the same thing. We go through. First thing I'm going to do though is I'm going to write this as a sum, just so I can get rid of that subtraction and see what all my terms are. And now I see I need to distribute, or you could have seen at the beginning, I need to distribute that 3. But I am going to take a little liberty here. I am going to move my variable terms around. So I'm going to make this negative 9x plus negative 5 is equal to 3 times 1 is 3 plus 3 times negative 3 is negative 9. And then we have the x plus negative 8. And then once again, we do some finagling here. We can't combine anything on this side, so this stays negative 9x plus negative 5. But this is going to be equal to the only constant term on this side is the negative 9x, so let's go ahead and write that down. Plus, well, then we get 3 plus negative 8. Well, that's actually negative 5. And once again, you can kind of see something's up at this point because we have the exact same thing on both sides of the equation. Now, technically from here, you could go ahead and say there's infinitely many solutions, okay? But if you go further, just like we did before, okay, and we do the steps like we would do in solving an equation with variables on both sides, we would add the 9x here to get rid of it. But in turn, that would actually get rid of the 9x on this side, the negative 9x on this side. So what we're left with is negative 5 is equal to negative 5. And now at this point, you can for sure say that this equation has infinitely many solutions because it is always the case that negative 5 is equal to negative 5. Okay? So that is always true, meaning this is always true, meaning that's always true, meaning that's always true, meaning the original equation is always true, meaning that it doesn't matter what you plug in for x, it's always going to be equal. Okay, you could plug in 0, you could plug in negative 50, you could plug in negative 87, you could plug in whatever numbers you want to in for x, and this will always be equal because in the process of solving our equation, we get down here and we get something that's always true. We get something that is obviously true. Negative 5 is equal to negative 5. So since we have something down here that's true, that tells us then that there are infinite solutions. We do have a couple ways of writing that. One you can think of is you can write a set symbol and use the infinity sign. That's one way you can kind of write that. But then my personal favorite is the double backed R. So it's basically an R with 2 backs here. And what this means is all real numbers. Okay. So if you want to try using that, a lot of people do like this now, and then when you show it to them. So if you'd like to use the R, double backed R, that means all real numbers. But what that means is any number that you plug in up here is going to give you the same thing on both sides. Okay, so this is going to always be equal. So that is an example of an equation with infinite solutions. So the difference here is, once again, let's just refresh, and then we'll look at a few more examples, and then we'll call this video to a close, is when you're solving an equation and you get down to the bottom and you get something crazy like negative 4 is equal to negative 2, or 40 is equal to negative 6, or 0 is equal to 20. Okay? Once again, you get something down here that's obviously not equal, that tells you there's no way to solve your equation. So in this case, there's no solution. There's no number that you could plug in your equation to make this true. Okay? There's no possible number that you could have. Infinite solutions, on the other hand, same process, so we do the same exact steps, except at the end we get something that's obviously always true. -5 is equal to -5. Okay? So you get something down here like 0 is equal to 0, 20 is equal to 20, 50 is equal to 50, -70 is equal to -70. You get something down here that, once again, is always equal. So that means any number that you plug in will give you the answer to the equation. It will work in the equation, meaning that it makes both sides equal. Okay. So with that being said, let's look at some more examples. Now, I do want to point out with these examples, and this is the way it is on any test you might take or anything going forward, is these kinds of equations will be thrown in with the other ones like you've seen before. So you can't just guarantee that an equation has a solution, an equation has one solution, or an equation has no solutions or infinitely many solutions, okay? So that's the point here is you need to work out every equation just to be sure, because you might have an equation that has a solution. You might have an equation that doesn't have a solution, okay? And that is the point in working these out, so that way you can tell what kind of equation you have. So when we look at number 1, looks very similar to something we've done before. Once again, we see the parentheses here. We need to distribute. But from here, I can't tell if this equation has one solution, no solutions, infinitely many solutions. Like, I can't tell from here. So I need to go through the steps in solving an equation, which the first step is going to be, I'm going to go ahead and distribute. So I'm going to write that as 6x plus 6 minus 3x is equal to 6 plus 3x. Now from here, people might see something might be a little up, but once again, let's just keep going, okay? Now, some people can probably go from here and say 6x minus 3x, that gives me 3x, but I am going to take the one extra step here for those that maybe need the help with it, and write it as a sum. And then I'm actually going to do the same, do something here. I am going to, since this is addition, just flip the terms around so I have the variable term first. But then here I can see, well, what can I combine with 6x? Negative 3x. Well, that gives me 3x. We still have the plus 6. Well, look what we have here. Technically, from here, we could say that that's infinitely many solutions, but let's just keep going on. Once again, we do this, it gets rid of the 3x's on both sides, so at the end we get 6 is equal to 6, which is obviously true. So that means, once again, if that's true, always true, then that's always true. Then that's always true, then that's always true, then that's always true. So that means our original equation has infinitely many solutions. So I'm going to use the fancy R here and say our solutions are all real numbers. There's infinitely many solutions. Once again, I'll remind everybody that this means all real numbers. Meaning any number you can think of, if you plug it into that equation, both sides will always be equal. Okay. Number 2, very similar here. We got some subtraction, some negatives here. I'm going to go ahead and distribute first, and then we can worry about writing things as a sum if we need to. So we're going to distribute a 6 here, which will give me 12x minus 36. On this side, we're going to have negative 7 times negative 2. That's a positive 14x, plus negative 7 times 4 is negative 28. And then once again, I'm going to just take the one extra step here and write that subtraction as a sum, so that way I can clearly see all my terms, see if there's anything I can combine together or not. But we can't on either side. Okay, so then we just go through the same steps that we did in the last section. We've got a 12x on this side, a 14x on this side. Just by habit, I'm going to take away the 14x on this side to get rid of it. But if I do it to that side, I've got to do it to this side. So 12x minus 14x, that gives me negative 2x, plus negative 36 is equal to negative 28. I'm going to take one last step of rewriting before and write that as minus 36, back as minus 36 again, just to make it a little easier on me in solving my equation so I have less negatives to deal with. Now we just do the two-step equation. Negative 2x is equal to negative 28. So again, to get rid of that, negative 28 plus 36, that's going to be a positive 8. Divide by negative 2, divide by negative 2. In this case, we actually get an answer. X is equal to negative 4. So just to show you, once again, these can be thrown in this equation. I mean, it definitely looks different than this equation, but once again, it's hard to tell at the onset if an equation is going to have one solution. So this is an example of one solution. The only number you can plug into the equation is -4. So that means -4 is the only solution to this equation. Whereas with the example 1 here, any number you plug in. So there's actually infinite amount of numbers you could plug in here to make this equation true. Okay. Now, last two examples here. Once again, do be careful. Okay, just because you look at an equation and you maybe think that it has no solution or think that it has one solution, work it out all the way to the end so that way you can clearly see, well, how many solutions does it have? Does it have just one solution? Does it have infinitely many solutions, or does it have no solutions? Okay. Once again, that goes with just doing the same steps over and over and over again, solving each equation the same. In this case, I'm going to distribute the 8. So we're going to have 8 times 5x, which is 40x, minus 8 times 3 is 24, is equal to 6 times -3 is -18x, minus 6 times 4 is 24. Now, some people might be looking at this and say, oh, there's minus 24, minus 24. Maybe this doesn't have a solution. Maybe there's infinitely many solutions. But we can't tell from here, okay? Well, actually, if you're clever enough, you can tell. This actually has one solution. But let's just continue on like we've been doing. So once again, I'm going to write this as a sum just so I can see what all my terms are. So I know what I need to add or subtract from both sides. So in this case, I need to add 18x to both sides. The reason for that is I want to get rid of it on this side. 40 plus 18x, 40x plus 18x is 58x. Ooh, that's a weird big number there. Technically, we still have the plus -24. Well, that's equal to -24. Once again, we still can't really tell what the answer is going to be here. So let's keep going. 58x minus 24 is equal to -24. So then we just do the steps of adding 24 to both sides. Okay, so if we add 24 to both sides, once again, the whole point is get rid of those 24s, and minus 24 plus 24. So we have 58x is equal to -24 plus 24. Once again, those go away, but what happens when something goes away? Well, technically, when that happens, we have 0. So you might be looking at this and saying, oh, well, that means there's no answer. Okay, 58 times something can't be equal to 0. Well, if you actually go through with it, if you divide by 58, you actually find that the answer is actually 0. Okay, and that is different. So this is an example I wanted to bring up because I want to make a point that this is actually an equation with one answer, and the answer is 0. Just because the answer to an equation is 0, that doesn't mean there's no answer. There's a difference between an equation having no solution and a solution of 0. Okay, this is an equation with a solution of 0. We get actually x is equal to 0 down here. This is an equation with no solution. We get something like -4 is equal to -2. Which once again, that's different. That means no number can work for this answer, for this equation, whereas only the number 0 works for this equation, which once again, that means that the answer is 0. So this is just one solution. One solution. Once again, I guess I should have did it with this one. The -4 here is the one solution. Okay, so once again, figuring out how many solutions something have, just solve it. If you solve the equation, depending on what happens, it'll be clear whether it has one solution, infinitely many solutions, or no solutions. Okay, and the last example here, number 4, same kind of thing. This one's a little tricky. Once again, we have this issue here where a lot of people forget they want to just distribute the 4, but I'm going to write it as a sum first this time so we can really see what's going on here. So what we really need to distribute, which in this case you can see now should be a -4. Okay. So we're going to distribute that -4. So we have 3x plus -13 is equal to, well, here I've also got to distribute a 7. So 7 times x is 7x plus 7 times 2 is 14 plus -4x plus -4 times 7. -7 is +28. So not doing anything with the left side still. So we still have 3x plus -13 is equal to, well, we can combine terms over here. So 7x plus -4x is 3x. You can maybe see where this is going now. We got 3x on this side, 3x on that side, plus 14 plus 28. That's actually 42. Now, once again, from here, you could probably guess what happens, but just to be sure, let's keep going and do the rest of the steps here. So let's subtract 3x from both sides, which once again gets rid of that 3x, but then also gets rid of that 3x. So finally, we get -13 is equal to 42. So once again, if we did all the steps correctly, we get some nonsense like this where we have, in this case, it's even more absurd because we have a negative number is equal to a positive number. That can never happen. Okay. So that means that can't happen. That means that's not true. That's not true. And that means our original equation is not true. So that means there is no solution, meaning, and I'm going to use the symbol for it, that means there's no answer here. Okay. Once again, this is the empty set, just meaning it's a set of numbers with nothing in it. That means there's no answers to this equation. There's no answers, no solutions. Okay. So once again, empty set, no solution. Okay. You get something like x is equal to 0 or x is equal to -4. That means there's one solution, and it's just whatever number you get x is equal to. Okay. But then you get something like 6 is equal to 6, or 5 is equal to 5, or 20 is equal to 20. You get something down here that's always true. 0 is equal to 0. That means all numbers are your answers. So that means infinitely many answers. So the last thing here is there's a little activity for you, which if you are virtual, unfortunately, I guess you can't really pair up into partners, but if you were in class or are going to be in class, we do plan on giving everybody a partner shot here. So being able to work with somebody to practice with this a little bit. But if you go through and work that activity, once again, make sure you read the instructions. So it's another one where you got to match up. It's one where you got to match up the answers on both sides. So like for set 1, set 2, set 3, and set 4, on each column, the answers are going to match up, meaning the answers to one letter on the left are going to equal to one of the answers to a number question on the right. So that tells you which box you need to put which letter. Okay. So just a quick rundown of the rules there. But once again, what you're going to do is solve each equation. So once you solve the equation, the answer to the question, what do you call a potato who reads the news? Well, once again, that means for question number 1, okay, you're going to get the same answer as you got with the question that's labeled C. Question number 2, you're going to get the same answer as the question labeled O. Okay, well, one of the questions labeled O because there's going to be more than one O. Same thing with an M here. So box 3, there goes an M. Box 4, an M. Box 5, another O. Box 6, an N. Then you have the dash. Then box 7, there's going to be a T. Box 8, an A. Box 9, another T. Box 10, an E. And box 11, an R. So what do you call a potato who reads the news? A commentator. Ba-dum-ts. So if you found that funny, thank you. It's a very punny joke. But if you didn't, then that's still okay. You got some practice in with some equations anyway. So once again, practice through with that. Make sure you can get those answers to line up. Make sure that that's the answer that you get at the bottom when you match everything together. Once again, that's good practice with a bunch of different equations just to see, and you can see the difference between some equations with infinitely many solutions, equations with no solutions, equation with just one solution, okay? But once again, make sure, go through, practice with all those. If you run into any problems, let me know. Once again, all these will help you on the homework. So there's a homework sheet attached to this. So go through, attempt the homework. Once again, if you run into any problems, let me know. But other than that, good luck on your homework, and thank you for